So,
Loud.
Good afternoon, this is Ruchi. I'm a junior pursuing biomedical engineering.
And I'm Shreet. I'm also a biomedical engineering major.
My name is Matt. I'm an industrial technology student.
So starting with the abstract, so as we know that 3D printing is one of the latest technology in the market. So 3D printing focuses on printing the samples and making sure that it is used in different kinds of biomedical applications like orthopedics. So our project mainly focuses on characterizing fracture toughness of 3D printed nylon 12, and we considered 4 different kinds of parameters, which is print orientation, print bed location, print setting, and print number. So for print orientation, we have 3 different orientations: XZY, XYZ, and ZXY. And then we have 3 print bed locations, as you can see in this picture: center, left, and right. And we have 2 print settings, which is mechanical and balanced. So mechanical is the faster print setting and balanced is the slower one. And we printed the total number of 72 samples from the 2 printers. So this is the Instron setup of how we set up our sample CD specimen on the Instron. So moving on, we can show how we fractured our samples. So this is the video of how we set up our specimens on the Instron and how we fractured it. So this is how we fractured it. And then moving on, analysis, Ruchi would take up that.
So for the analysis of results, we did CT scan and SEM. So CT scan was done on the specimens before we fractured them, so we can locate where the voids of the sample were. And we only did CT scan on 2 specimens as shown here. And one of those samples, that was a balanced sample, and the other one was also balanced. There were 7 voids in that one, and there were only 2 big voids in this one. And the reason that we're looking for the voids are to see if the voids are stress sources for the crack propagation once we start fracturing. And for our results, we looked at the fracture toughness value, which is known as KQ, and compared it to the fracture toughness values of other printer types, SLS printer, and also the ASTM standard. And as you can see in the blue, the graph shows that the fracture toughness value that we calculated from the HP printer was higher in comparison to SLS printer nylon 12 and also the ASTM standard. And also comparing the mechanical and balanced print settings, we noticed that the balanced was a better print setting which produced higher fracture toughness as opposed to the mechanical. And this is also just the orientations, XZY, XYZ, and ZXY. And we noticed that the ZXY orientation, which is the middle layer, had the highest fracture toughness value in comparison to the other 2 orientations. And yeah, Matthew will talk about the visual inspection.
So we did a visual inspection as well to try to match the data that we got with our samples. So a couple things we wanted to look at. First off, we want to look at the 2 types of cracks that we got. We have a linear crack and we have a crack that propagated in 2 different ways. We want to look at elephant skin, which is a surface material, if it's smooth, if it's got notches in it, or if it's got that nastiness on it. Also thermal bleeding. Darker the piece is in comparison, something like this is very, very light. Lighter, darker. Darker means more heat been absorbed into the part during the printing process, which is not good. Kind of means that it got burnt. And we wanted to we're going to look at that and see whether we can match the amount of thermal bleeding for the calculated KQ values. So in conclusion, like I said before, the balanced is overall the better print setting. It's slower, has better KQ values, less thermal bleeding, had a better surface finish, and had less of the 3 prong cracks. For our future work, we're going to try to continue this on, either pass it off to another senior project group, continue to try to characterize these the best we can. With only 72 samples, we are partially able to characterize it, but to truly characterize it, we're going to want about 300 samples or so, and just continue on from there. I'd like to thank Jabil team and Printing Additive team for all they've done for us. They really helped us out. They taught us a lot, and we're just kind of happy to go.
Thank you so much.